This conference will now be recorded.
All right, this is a continuation of the 6.3 notes that we were going over in class. I have a couple examples we skipped because they were similar, and I'm going to go through those for you right now. This one says use a formula for negatives to find the exact value. So remember we learned that sine of an angle and tangent of an angle were odd functions. And what that meant was if there was a negative inside the function, it could be pulled to the front and it would be the same answer. And we learned that cosine is even, which means that if there's a negative inside, it's the same as the original function. So that was what we learned, and that had to do with symmetry. So because sine is an odd function, we're going to pull this negative to the front, and we're just looking for what is the sine of 3 pi over 2. So if you think about where 3 pi over 2 is on your unit circle, which you should start almost having memorized by now, we've done a lot with the unit circle, it's down here, and that is the ordered pair on the unit circle. That would be 0, comma, -1. So sine is always related, remember, to the y value. So this is negative of -1, which means the overall answer is a +1. Okay, let's do cosine of -225. Again, that is an even function now, so a negative is going to actually just turn into a 225. This is using, remember, what we know about odd functions and even functions. So 225 is in quad 3. It's a 45-degree angle. So that means it has the ordered pair negative square root of 2 over 2 and negative square root of 2 over 2. They're both negative because it's in quad 3. Cosine is related to the first item in the ordered pair when you're on the unit circle. So this is going to be just negative square root of 2 over 2. And then the final one in number 18 is tangent of negative pi over 4. So when we're looking at that one, we need to realize that it's an odd function. So we pull the negative out. So we're doing tan of just pi over 4. And where pi over 4 is in quad 1, and that's a 45-degree angle again. So that's the ordered pair square root of 2 over 2 and square root of 2 over 2. And they're both positive because you're in quad 1. Now, the tangent is found a little differently than finding sine and cosine. To find tangent, you have to do y over x. So negative is for the negative out front, and then square root of 2 over 2 over square root of 2 over 2, because that's y over x. So that's just going to be -1. Okay, so let's move on to the next slide. I did 3 of these together with us in class, and we're looking at number 43. So the directions say, refer to the graph of y equals sine x or y equals cosine x to find the exact values in the intervals 0 to 4 pi. So since this is cosine, I'm going to just roughly sketch, again, what cosine is doing between 0 to 4 pi. So remember when I did that in class, I kind of counted by pi over 2s because that made it a little easy. 3 pi over 2, 4 pi over 2 would be 2 pi. And then 5 pi over 2, 6 pi over 2 reduces to 3 pi. Then 7 pi over 2, that's supposed to be a 2, by the way, not a 6. 7 pi over 2, 8 pi over 2 is 4 pi. So there are my different measurements. And remember, cosine and sine, when there's no transformations involved, which is something we learn about later, they fluctuate between -1 and 1. Cosine starts up at 1 and goes down all the way through pi over 2 and then to pi down to -1. It's back at 0 at 3 pi over 2, back up at 1 at 2 pi, then it repeats the pattern of down and then back up. And remember, this is only a small portion of that wave. So the question says, when does cosine have an output value of 1, which is its y output value? So if you imagine, I'm just going to take a different color, we'll do red, and drawing a dashed line through the y value of 1. We can see that on 0 to 4 pi, that intersects that wave 3 different places. The answer is those x values, and our x values here are our angle values. So 0 is one of them, 2 pi is another, and then at 4 pi. So there's the answer to number 43. Same idea for 15. We're going to be doing the tangent function though, and we're only doing it on an interval of -pi over 2 to 3 pi over 2. So that's because we had to go backwards into the negative angles because remember, tangent has some undefined areas. So I'm going to draw this picture down here. So we need a little bit of space behind us. So -pi over 2, pi over 2, pi 3 pi over 2. And notice this is not brackets because remember, tangent is actually undefined at any of those pi over 2's. And it actually is undefined also at 3 pi over 2. And that's because when you make the ratio, you divide by 0. So if you remember from our drawing, tangent kind of does this in between those, just kind of getting a rough sketch. Okay, so this first question asks, when does tangent equal 1? Well, the only time tangent equals a 1 or a negative 1 is when you're dealing with a 45-degree angle, because that's when you get square root of 2's over square root of 2's. So essentially, we're asking if tangent equals 1, how many times does that happen from here to here? And it's going to happen twice. So the first one it's going to happen at is when you have a pi over 4, because pi over 4 is when you get those two pieces as your ordered pairs. So one of them is pi over 4. The other one's going to be right here, but it's also going to be something over 4. So remember, this is 4 pi over 4, so this one would be 5 pi over 4. And again, if you need to look at the unit circle to see that, you would look at places where your y over x would equal a positive 1. So that happens in quad 1 and quad 3, essentially. And that's the only two places that's going to happen on this picture. This one's a little harder. So this is square root of 3. So that's square root of 3 over 1. Imagine that, which means think about that as being a square root of 3 over 2 and a 1/2, because that's the sides that we usually see on our unit circle. These are the ordered pairs. So let's think for a second where that would happen. So that means our y value is this and our x value is this. So as an ordered pair, that's 1/2 square root of 3 over 2. It's a positive tangent value, which means it has to happen in quad 1 and 3, because that's the only place this tangent can be positive. And let's look at what would that be. So that's 1/2 and then square root of 3 over 2 for the y value. So that's a 60-degree angle because that is a short x value and a tall y value. So that's going up higher. Again, you should have sort of some of this memorized from looking at the unit circle. So both of these are going to be 60-degree angles. Now in terms of radians, that's pi over 3. This would be 3 pi over 3 for pi, so this is 4 pi over 3. So the two angles, and that would be the only times that it would equal that square root of 3 between here, because it's only going to cross those two things twice. So that's going to happen at pi over 3 and 4 pi over 3. So there's those two problems worked out. And then we did 52 in class. So that's the end of this video, and I hope to see you guys rested from your Labor Day weekend on Wednesday.